I would like to give Mantel Group a huge thanks for sponsoring tonight, the venue and the goodies, the food. So yeah, thanks for that. These good folks are both from Mantel Group, so you direct your thanks in that direction. Mantel Group is about empowering business success through innovation, tailor-made IT strategies and implementation. One of the people we have speaking here tonight is a principal consultant, data science, machine learning and AI at Mantel Group. He's also an entrepreneur with a storied background, actually leading industrial AI research in a large variety of areas. Not the first time we've had you with us either. So yeah, he's also done a talk called Challenges with Implementing ML in Business. So go look at our meetup history, you'll find that. So, and I'm going to let Samuel introduce his other colleagues speaking tonight, but please do join me in giving Samuel Irvine Casey a round of applause. And welcome to that. Get away.
I'll take your mic off here. It is an absolute pleasure to be here. Yes. Yes, I'm delighted to be joined by Elaine. She is one of my colleagues at Mantel Group. She is a machine learning engineer and has to actually, do a lot of the things that I talk about doing. So I thought, why not bring her along so we can, get multiple perspectives, not just mine. Yeah, where are we from? Mantel Group, just a end-to-end IT consultancy spanning data, digital, cloud, and cyber. Elaine and myself sit within the data team, within the AI and ML engineering capability more specifically. In terms of tonight, it's going to be pretty loose, pretty fast. That's just how we do things. But we're hoping that by the end of it, you guys will have a pretty good understanding of adversarial AI and some more practical things that you can do in your own model development to prevent, protect, try and reduce the frequency of this stuff happening to you and your models. In terms of rough flow, I'll kick off with a bit of an intro, talk a little bit about some of the types of attacks and kind of attack surfaces for models. I'll then pass to Elaine and she'll talk through some of the kind of things you can do and walk through some more tangible examples and, like mitigation strategies that can be applied. And hopefully that can then just give you a bit of a checklist of things to look for yourself when you're doing your own models. And then we'll finish up specifically just with a little conversation around large language models generally, because while adversarial AI, is important across like the broad scale of machine learning, it is particularly interesting in the field of large language models because, as we see, there's a lot of things that are available now that people can just take and use and not necessarily understand the ramifications of what these things can actually do when they're just let unfettered in the wild. So to kick things off, just want to start with a thought exercise of, here's an image, is this adversarial AI? Now, again, you probably think, I have no idea, I don't have enough context here, but you're at a meetup about adversarial AI, so the betting people in the room would probably say yes, and you would be correct. However, it's not something that is adversarial for us, it's not something that we can see, it's something that a machine can see. And this is a really, it's a very easy example, very straightforward example about how easy it is to manipulate an image or manipulate any piece of data to contain different information, in this case, a little hidden message that says hidden data can exist anywhere in binary without actually changing the image. And you can see here that on the left side, you see the original, on the right side, you see the hidden message, and in the middle, you've got the normalized image across from that.
Similar concept to having a watermark.
Very similar. Yeah. And I think this is a really just visual example of how models interpret data. And how models interpret data is very, very different to how we interpret data. Onto something a little bit more sinister. We're going to do the tried and true, trying to get audio to work. Where's my little cursor? All right, yeah, here we go.
Have you started recording
Yeah, I was talking about that.
The union said it was proposing to purchase all of the assets of United Airlines, including planes, gates, facilities, and landing rights.
So we can see there, that's the original. That's an audio recording of just, as it said, purchasing assets for United Airlines. But what we can see is that with some limited manipulation, we can get the model. Now it's coming back down here. Speaker notes, man, failing me. What we can do is we can see that when we can make limited manipulations to the audio, run it through the same speech-to-text model, and get a completely different outcome.
Specifically, the union said it was proposing to purchase all of the assets of United Airlines, including planes, gates, facilities, and landing rights.
So you can see between the first and that, to humans, no difference. But in terms of what was run through the speech-to-text model, big difference. And especially if you start thinking about how you could apply attacks like this in people's homes with Alexas or with Siri or with Google Assistants, that this is something that poses a much larger potential threat. Corporate environments, very similar. And if we then think about, well, what is actually the difference between those two clips, we can see this is what was added. So nothing. Little bit of noise, indistinguishable. There's nothing in that is in particularly that's not comprehensible. That's not English. That's not any sort of, just hidden subliminal message that's being played underneath. That is just a little bit of extra noise that entirely changes the predicted output of the speech-to-text model. Interesting, scary, but also very interesting. So, what is adversarial AI? Those were some examples, but I'm really partial to this definition from the Department of Homeland Security, where we think about, if you look at the right-hand side, we kind of define adversarial AI as an AI-based attack on an AI system or an AI-based attack on a non-AI system. For the bottom, the AI-based attack on a non-AI system, we're not really going to deal with that much in this meetup, but an example would just be like using machine learning or AI techniques just to kind of commit fraud, just general, social engineering or attacking like software systems, stuff like that. A good example, if you're interested in that, would be, the case that happened over in Asia with the deep fake of the CFO. So essentially a group of bad actors sent an email wanting to transfer some funds. They hopped on a unnamed video conference call. Don't want to name any names. And on that conference call, every person on the call was a deep fake except for the poor accountant that was the one being duped. And they convinced this person to transfer $20 million out of the company. So that's just an example of an adversarial AI attack, but on a non-AI system, because it's just like, your typical financial fraud. So what we're going to focus on is the top right, and that is using like AI techniques or, adjacent techniques to attack specifically machine learning models, AI systems, etc. Quickly, why is this important? Well, if it wasn't apparent from some of those examples, it's here. That's something that, I think that it's not necessarily, it's not a super new concept, but it's something that is definitely, emergent. It's like, we're seeing these attacks become more and more prevalent. We're also seeing it be it's more like unsuspecting. It's newer for a lot of cyber people in organizations, for a lot of technologists, a lot of established technology teams. It's something that they haven't necessarily encountered in their day-to-day, as much as more traditional, kind of software attacks. And it's critical. This is the sort of thing that if you're running machine learning models in production in kind of any way, shape or form, this sort of attack would be a critical incident. So that's something that, it's definitely important to think about. So moving on from some more theoretical examples into some actual examples, I wanted to provide a couple of different things that have happened in the last few years where adversarial AI attacks have actually occurred in the wild. This one, again, it's a relatively simplistic example. It's something that we'll touch on a little bit towards the end when we get into large language models more generally. But this was an example where Bing Chat released this AI assistant, and very, very quickly, with very limited prompting, users were able to get it to reveal its entire prompt to them. And they were able to essentially get the entire inner workings of the chatbot with just the user interface. They didn't have to do any other sort of attack or any other sort of injection. They were just able to talk to the bot and get it to reveal the inner workings that then they can use to either train their own similar assistant or just to get an idea of how it works so they can potentially try and manipulate it later. In this case, apart from brand reputation stuff, it's probably not as big of a deal. Where it starts becoming a big deal is when organizations connect these assistants to back-end processes. And an example in the US, there was a car dealership that had a kind of an AI assistant sales agent that you could talk to and actually kind of go through the car buying process. That hadn't gone as far as being linked up to an actual pull the trigger, pay the money, get the car, but it was basically all the way through to quote order form, and then you can submit it and someone would come back to you with all the details. And they were able to manipulate that again with trivial, kind of actual input to get them to sell cars at a horrendous discount. It's like $1 or something, and get it to confirm that you would be able to buy the car for $1. So you can see that if this stuff's unchecked and you're not thinking about it, it's very easy for it to snowball into something that then does become a problem. In a more theoretical, technical example, this is a really fascinating paper. If you're interested in technical papers, this will be available at some point when the video goes up. Definitely read it. It is, really, really interesting work. Essentially, what they wanted to do is see whether they could inject a kind of backdoor attack into, a bunch of different open source neural networks that were running in mobile applications. And so what they were able to do is they were able to get, the SDK of a lot of different mobile applications, find the ones that were using some sort of TensorFlow or TF-Lite or some sort of kind of open source architecture. And then once they found the apps that had that, they were then able to inject their own little neural network into that total graph, which would act on a trigger. And basically what they were doing is they were taking, go over here, got a nice little diagram that I stole from their article. If you have a look here, essentially what they would do is these are all kind of image-based apps. These are image-based models that they were specifically trying to target. And what they would do is they'd take a public data set and they would train a model called a trigger detector. And what that would do is it would basically be if you see a trigger in the image, it could be a little, in that cat image, you can see a little exclamation point or a number or a letter or something. If you saw the trigger, give me an output that I've defined. And what they would do is that essentially, if you look at the bottom right there, they would create essentially this separate neural network that they would then inject into the application that would run in parallel with the original neural network. So rather than trying to bypass the neural network by, trying to find the best, best data input to get the data output, they were just bypassing it altogether. And if it detected the trigger, it would then trigger the conditional module, which would then give the response that they were wanting. And it's really, really it's fascinating that they were able to get it to work, and they were able to get it to work with an incredible accuracy percentage across the apps that they tested. So they were like, it was like, I think 25 apps they'd tested, and 23 of them they were able to successfully inject into the app and get it to bypass whatever the classification was that they were trying to bypass. And this is a good example too, I'll talk about it a little bit later, of not needing a huge amount of information in order to actually attack them. In this case, they knew that they were using TensorFlow, they knew they were using TF Lite, they knew like a little bit about the architecture, but they didn't have the underlying training data, they didn't know, any of the parameters or the weights of the model. They were just able to use their own model, and they were able to inject that in and able to get the results that they were wanting. So again, a really interesting paper, would recommend reading it if that's your thing. Just going to leave this on the screen too, just for the video. Again, that's a really good website, atlas.mida, just for a bunch of resources around adversarial AI specifically. So again, if you're interested in further reading, that's where I would recommend you look.
Great resource.
Yeah, it is. It's a really, really good resource. No worries. So that's an intro. I know it's a bit of a whistle stop, but hopefully that gives a bit of a, gets you thinking. Now I wanted to talk a little bit about the actual attack surface. So we know now a bit of examples. Now I wanted to talk a bit about taking things back to more of a generalized view of machine learning. What are the attack types and what are the attack surfaces that those attacks can be used on? This is a very, very simplistic view of a machine learning model lifecycle. Again, this isn't news to many of the people in this room, but with any sort of model, we want to prepare our data. We then want to take it through the model training lifecycle, deploy it, and then hopefully, if you've got good ML ops, we're then monitoring the model when it's in production, if it makes it to production. Then there's a nice little model retraining cycle in there, again, that everyone should be doing. And, the model works and everyone's happy. And at each point in this journey, there are different opportunities for adversarial attacks. If we have a look at, again, this is a non-exhaustive list. The MITRE Atlas has a much better exhaustive list, but here are some really kind of common groupings of adversarial attack. And I think probably the best things to focus on. You can see that they're split into two primary categories: attacks that are done during training and attacks that are done during inference. And kind of what they can do and how you protect against that will differ depending on the stage of the modeling lifecycle. I've put data access there just because as a general rule of thumb, the more information that someone has about the model, the easier it is for them to attack it. So if they have access to the underlying data, it's they can do a huge amount of things that they would otherwise not be able to do if they didn't have that data. So that just in and of itself, if a bad actor gets access to data, it's already bad news. We then have the most common type of attack in the training phase is data poisoning. And that's where you're essentially trying to train a model that is going to behave normally. It's going to do all the things it's supposed to do, but you're training it to do what you want it to do by poisoning the data. So this is a really hard thing to detect if you get a model that actually goes into production that has been poisoned, because the model will be performing as it's expected to. And if you've got a nice test set that you're training against and you're validating against, it'll say you're performing well. It'll say that you've got a high F1 score. It'll say your precision's good, your recall's good, but the data itself is corrupted. This is probably the biggest issue when it comes to using open source data sets. So that's probably where the biggest risk is. So it's important, and Elaine will talk a little bit about this, but it's just important that when you are training models using data sets that you just find on the net, that there is some sort of cursory, data analysis done or distribution done or, review just to make sure that it is what it's supposed to be. If you've got a sentiment classifier or a profanity classifier or something that, the words that should be profanities are and the words that shouldn't be aren't, just so, you're not inadvertently training something that is going to then let you, like happily, use slurs or something like, which is obviously not something you want. In terms of internal, this is probably less of an issue if you've just kind of got good internal security practices. Like obviously, if you guys have access to data and you want to poison it, you kind of can. Like, that's something that you have the access, but again, you'd hope that, organizations have good security that would be able to detect that, or you've got, multiple people working on labeling problems and model training and retraining and stuff like that. So you limit that possibility by having those checks and balances. As you move over to inference, there are kind of two core types of attacks that we see frequently. Evasion is what I spoke about earlier. A lot of the examples I used were evasion attacks, where you're essentially trying to bypass the model to get an outcome you want. There are various ways of doing it. The backdoor attack was an interesting way where you're kind of bypassing the model entirely to get the result that you want. There are other interesting ways, which were more the very first couple of examples that I showed, where you're trying to, these are like these kind of single step and iterative gradient approaches, where you're essentially trying to find the minimum change to the input data to get the classification you want. And that's what we saw with like that audio example, that like you can just add a tiny little bit of noise and then that gets you the output that you want. The only thing with evasion is typically you need access, like some level of access to the model. Like you need to know the architecture, you need to know the parameters, you need to know like what model is being used. And it's very hard to do a lot of these attacks if you're dealing with a black box model. Not impossible, but very, very hard. And that's what then leads to the Oracle attack, which is where you don't have a fundamental understanding of the model, you don't have the data, you don't have the architecture, and you're wanting to find out. And so really in the Oracle attack, what you're trying to do is essentially like interrogate a model to get the inner workings, which you can then use to train your own like replica model to then do the evasion piece. Because once you've got your replica model, then you can, do all kinds of gradient stuff, and then you can use that to attack the original model. And, in the Oracle, like if you think about things like automation with machine learning, like, automated loan approvals or like pricing calculators or things like that, or you've got like large language models where you are kind of going through a process. It's quite easy to just ask it a bunch of questions and only slightly change the data that you're using in the question and just write down the answer. And if you've got, for example, like, a home loan discount calculator, and you're trying to work out, well, what's the best way that I can get the best discount, but I don't know how the model works, you might sit there and say, well, this is my occupation, this is my age, this is where I live, and see what it gives you. And then you might do it again and just change the values a little bit and see what it gives you. And if you do that enough, and like typically programmatically, you can then get a huge list of key pair values, which you can then use to train your own model. And then that way you go, okay, in order to get the best discount, I say I'm a doctor and I do this and I do that and I'm this year, how many years old, and it will give me the best discount. And so again, the Oracle attack really highlights having really robust monitoring, logging, like of your application to prevent, like massive, like continued, attack on the actual like endpoint itself. And so then if we think about it in context, this is just kind of like a loose mapping of the attack types back on the attack surfaces. So you can see that, as you've got your inference, you've got training data, you've got the model, and then you've got the person, making inference of the model. You can see the different points of where, it's applying. Poisoning at the start, evasion kind of at the start of the model, and then extraction out at the end. And the last thing I want to talk about before handing to Elaine is the differences between, your black box, your gray box, your white box models. And again, this is kind of a bit of a repeat of stuff I've already said, but it's a really nice like summary of it. So I like kind of including the slide, is that in general, the more that the attacker knows about the system, the easier it is for them to attack it. And so If you have a white box model, like the most things can be done. The most attacks can be done. That's just the nature. Black box model, typically harder, but as you can see there, like you can use things like Oracle attacks to understand a little bit more about how the model works, which then makes it a gray box or white box, and you can then just go from there. So with that, I'm going to pass to Elaine to talk about some practical suggestions to protect against these attacks.
Okay. Thanks for the intro, Sam. So yeah, I guess on this topic, it can get really theoretical really quickly. So I just wanted to bring in some case studies to illustrate how these could actually happen and how you can mitigate these risks in practice. And also, I'll include a quick checklist of things that you can actually pretty much start to consider right now. So let's take a look at some of the more down-to-earth details about how you might actually run into these issues in your own work. So looking at the machine learning application lifecycle, I'm not going to describe it. I'm sure everyone's seen some variation of it. We've had one just before in previous slide anyway. But adding adversarial AI practices on top of this can seem a little daunting. So for example, you might want to get started, but you've got questions such as, where could the attacks occur? When should I start thinking about it? And do I need to think about this now? The short answer is that adversarial attacks can occur at any stage of the machine learning application development lifecycle. And you should start employing adversarial thinking as soon as possible. And you should think about it throughout the development, deployment, and operation of your application. Similar to traditional SecOps, adversarial thinking is most impactful when applied early and following these principles of shift left. And adversarial thinking is a collaborative journey, and it's important to be mindful when there are other stakeholders involved that you bring them along on the journey, because it's likely that they don't have the same understanding of the technology as you do. So you'll need to think about how to frame and communicate the risks in a way that kind of makes sense to them, and you need to convince them that this is a priority for you and your team, which it definitely is. Understanding the ways in which your application is vulnerable is important, as it helps you to prioritize potential risks, as well as plan your mitigations and overall improving the security and performance of your application. So let's take a look at a few examples and approaches to make this a bit more concrete. In this first example we have, it's to set the scene a bit, this is an insurance provider that uses an OCR tool to automate their invoice processing. So the attacker would be a customer of said insurance company. They'll be submitting a invoice for a claim. That could be a legitimate invoice or not. And what's happened here is they would use a modified version of this where they add noise to interfere with the extracted value. So kind of similar to that image that we saw earlier, where you can just add a little bit of noise and it can completely change the way that the model interprets that. You could modify the document so that maybe you can add some noise so that it changes the decision to boundary. For this example here, it goes from $1 to $100 really quickly. And this is a perturbation style attack where the attacker modifies the input or query to get their desired outcome or response. It's not all doom and gloom though. We've taken a practical lens to see how we can reduce the risk of fraud like this with some following considerations and mitigation strategies. So to start off with, I'll say that definitely it's worth not trying to reinvent the wheel all the time. It's like, this is an established insurance company. They'll definitely have rules internally about, if customers on this type of plan, these are the types of products that are covered. And, there's kind of an idea of how much product would probably cost, how much you'd cover, even if it's a soft limit. For example, if you're trying to make a $30 physio claim, but then you're trying to get that to be extracted as $300 instead, there's probably some kind of internal rules that can be applied to say that, hey, maybe it's not that reasonable for a 30-minute physio appointment to be $300. And you can kind of build rules around that to make sure that when there's outliers like that, you can have some sort of manual flag to get that reviewed. So we can also introduce other components in the system like spot checking and auditing, so just checking the outputs of the model here and there, as well as a triaging process for large amounts or low confidence results. So like what I said before, if it's a much larger amount for that product than we're usually used to, that's probably a good case for a manual review. Or if it's, you can get a confidence score from the model itself or another model that kind of looks at what the model has said based on the input. And if it's a low confidence result, then you can also flag that for manual review. And a key call out here is that you don't always need to perturb much for the attacker to gain even just a little bit over time. So they can do a little bit every time and have big gains over a long term, I guess. And your business needs to understand the risk versus impact trade-off here, because maybe they don't care so much about like a $1 to $10 thing. But, if it's really important that we get the dollar value right, maybe we can build another model that predicts outliers from what you're used to seeing for that kind of product. Or you can build your own tool to detect edits to invoices or claims documents, or you can bring in another product that can do that as well. And to move on to the next example, we're going to look at a media company that uses a headline helper tool to help their editorial team write better headlines. So for this context, better headlines means grabbing the reader's attention. So that's more viewers, more clicks on the post, and if applicable, and the post is behind a paywall, then more subscribers as well. So what they would have done here is put together a headline helper tool using a large language model to generate the text, as well as a neural network to predict the number of new subscribers the headline is likely to make. So what they've done is use headlines from previous articles along with subscription information based off when users click through to the subscribe page after seeing said headline and hitting the paywall. So the machine learning team here have done a good job at trying to implement machine learning ops practices and made sure to track the performance of the model to compare this to see how well the predictions worked. And the tool functioned really well for a time, and the predicted subscriptions matched what they would actually what was actually seen. But then after a while, the generated headlines became less and less valuable in terms of new subscribers. Now, what went wrong here? It turns out the team had not accounted for the fact that generated headlines would make it into publication, and that on subsequent retrains of the model, the synthetic headlines would also be included in the training data set. So while there's no bad actors, and it doesn't seem like an attack in this scenario, the example follows the pattern of a poisoning attack, in this case, inadvertent. So it shows that adversarial thinking during the design phase of the model training is important. Mapping data flows during the solution design would have easily prevented this situation, or to surface this possible attack vector, and a mitigation strategy could have easily been prevented earlier on. So in particular, we can see that adding synthetic headlines to the training dataset reinforce biases that were already present. This leads to overfitting and therefore reduced predictive power. In this case, using adversarial thinking and asking the questions like, who is able to interact with the training dataset? Have we validated the quality of our data? Have we mapped the flows of our data and validated the distribution of our data in the EDA process? All of these would have likely revealed to the team that, in fact, there was a feedback loop in their system, and that they would have been able to mitigate this in the design phase to begin with. And we see this pattern all the time in other applications, very often churn models, for example. So in particular, leveraging their existing editorial or change tracking platform, they can, if they're able to build that into the system to market when those headlines are produced, it can help to reduce that coming back into the flow of retraining. On the other hand, and maybe if it's not able to be introduced specifically into part of the editorial workflow, it can just be marked or logged later on. And then you can sort of develop another tool on top of this to make sure that those pieces of data are not introduced back into the training data set. This example highlights two things. One, that attacks don't have to have bad actors and can be inadvertent. And secondly, that understanding the business domain is really critical to understanding the vulnerabilities of your application. Moving on to the next one. This scenario here is with a parking provider, say with an off-street parking provider that hands out a fine. So maybe you've parked somewhere that's a 60-minute parking and you've parked over and you receive a fine, or you park somewhere where you actually need a residential permit in certain times and you haven't displayed that, so you've gotten a fine for this. So the parking provider is trying to automate the appeals process for this, which is usually manual, by having you, when you get your fine, you go onto a website, and then to appeal it, you say, you kind of state your case, upload any evidence that's relevant, and then the large language model will output a response that, including taking into context like any terms and conditions if it's a parking lot, or any applicable like local laws or rules for the specific time. So say at Eden Park, you can't park on the side streets at certain times unless you're a resident. So any additional context like that. And then what you get out is a response that details, given your appeal, it gives you basically a yes or no. Will your fee be waived? And then a little bit of a reason why that has or hasn't gone through. So when we're looking at automating this process, there's a range of considerations to visit before implementing the technology into a customer-facing solution. We want to make sure the system is fair, usable, and logical, and we want to kind of make sure it mirrors the manual process that's in place at the moment. We want to make sure to clearly define and limit the range of actions the system could take, and as well as giving the customer the right level of information around the appeal and the explicit decision factors that we can give, but don't engage in behavior such as brute force attacks or attempts at prompt injection. You don't want to reveal too much about the inner workings of the system, but you also want to give enough information so that it's clear why or why not they've got their appeal accepted or not.
What's HIES?
Oh, that's human in the loop. Yeah, human in the loop.
Human.
Human in the loop. Yeah. Okay, so for example, say if you're parked in an area that's, example with Eden Park, where you live on a street that is normally like just normal parking, but then during event times you have to be a residential, live in the area pretty much, have a residential permit on the car, and then you'll be all good to go. But the attacker, say, has gotten a fine and they're not actually resident there, they don't have a parking permit, but they've realized that on the appeals website that the parking provider actually doesn't have the information. Yeah, it doesn't have the information, so they're like
Instructions so you get to.
So that they don't have the instructions they don't have the information for that. So someone's just figured out that any time that you say, hey, I'm a resident here, without any explicit proof because they have nothing to check against, they're just going to approve it anyway. So the attacker decides, I'm just going to park here every time because I know that I can just appeal it in this way and I'm always just going to get accepted every time. They spread this information around and then everyone's parking there for free. So other things we want to do is prevent, yes.
Just wondering if this is a real example, and if so, where did you get it from?
This is theoretical. Yeah.
I was wondering whether this system would have passed some kind of ethical review as like an appeals process for humans being decided by a machine. So
yeah. I think we've combined a combination of a few case studies we have seen for an Oracle attack, and I thought of this use case. Okay, I thought of this use case specifically because I thought I was really smart and found an area kind of near my gym where I could park and ride. So I was parking there and I received 5 parking fines in 1 month. Because I didn't see the signs around and I was like, oh, this is all good. I'll just park here, take the bus in, we're sweet. And because I hadn't gotten the fine till 2 weeks later, and then it rolled up and then turned out I had 5 of them. So I was like, okay, I feel like this is a good example. And I've seen online that this is something that could be taken on by an LLM project, but I haven't seen it in practice and it's not a client that we're working with or anything.
Are you monitoring if any attacker is attack my model, or you are preventing it from attack?
It would depend on the attack. Yeah. So if they're doing some sort of Oracle attack, there are quite easy ways to monitor that just by rate limiting use. So if you've deployed a model to a endpoint and it's available for people to interact with via that endpoint, then just by authenticating that endpoint and rate limiting it, it means that if then Elaine comes over and programmatically hits it 1,000 times a second, it will deny her ability to do that, and it will flag in your logging that someone's trying to smash this programmatically. Obviously that's not perfect. So if someone was really meticulous and logged on every hour and asked a question every hour for 5 weeks straight, they'd probably get a pretty good data set out of that, but there's not much you could do there. That's just kind of, if they want to do that, they're going to take the time. In terms of other attacks, it would be more around defensive mechanisms to prevent the attack to begin with, because it's a lot of things if someone knows how your model works and they can then prompt inject it to, get the outcome that they're wanting, it's hard to kind of get the model to identify that it's being prompt injected while it's being prompt injected. But you'd want to be looking at considerations before putting it to production to see if you can try and reduce that likelihood beforehand. Or alternatively, for more traditional machine learning use cases, examples that Elaine spoke about, just data validation you know, like if you're doing like an image recognition, you know, like form extraction use case, just mapping the fields that you're pulling out to existing tables that you've got as a validation method, that's another way of kind of trying to prevent this. But it's a cat and mouse game between prevention and detection for these attacks.
Okay.
Yeah, it's actually a good point. It's something that I was going to talk about as part of this as well in the mitigation strategies. So preventing these brute force style attacks actually improves the scalability and cost of the application while also hardening security. So obviously if you're getting attacked over and over again, like thousands of times a second, the cost is going to add up, as well as maybe your service might not be available to other people because someone's just hogging all of it. And yeah, I guess another thing here, we thought about, this example is really easy to, I guess, stop that particular like brute force strategy, because it's pretty practical at a point. You're gonna, you go on the website, you've put your notice number in or something. There's probably only like a couple tries that you'd be given to appeal it before it goes to a manual person. So it's a kind of an easy example to put that limit on. So you can, yes.
Coming to the situation that you're logging every hour or every half hour capture, or would that obviously be some form of defense?
That wouldn't be a bad form of defense for like if it's a human doing it, like if a human's coming in and every hour they're logging in and they're, wanting to use a service like a chat window or an application, automatic application form or something, that could potentially, it wouldn't stop them, but it could like just make it more annoying for them to do it. But really, like the captures are obviously going to solve your programmatic attacks. But yeah, if you've got a bad actor that just has nothing but time, like it's harder to identify that. You would have to go down the route of, having some sort of monitoring for just suspicious or repeated login patterns, and that would be more like almost another model in its entirety around, the average customer. Like a real example we're using at the moment is actually with a media company, where they're doing like article recommendation, and they have patterns on what their users like typically will read in a day and what they'll typically search for in a day. And so they've just put some very loose guardrails around that limit users to use this new functionality. I think it's like 20 times or something, right? And so if you use it more than that, it converts.
That's why I'm still trying to really grasp as to how this can even happen if you've already got security back in fact.
And that's a good, I think that's probably one of the good takeaways, is that the majority of considerations is just fundamental good cybersecurity. Okay. And so if you have, you think about data poisoning, for example, internally to a business, if you just have really strong access controls and like, IAM permissions, and, Elaine is the one doing the model training, and so only Elaine has access to the data, and maybe her colleague has access to the data as a bit of a two-person check. Like, there's no reason why I need access, or you need access, or anyone here needs access. So if that's the case, then already you've limited the problem space for how easy that could happen. Same thing with, if you're deploying models, rather than just deploying it into a container somewhere that is just like some, unsecured cloud container, deploying a model on, SageMaker or on Vertex or something like that. Again, I make no comment on any of the ML platforms themselves, but as soon as you do that, or, or you're deploying something on Databricks or on Snowflake, like you're adding a layer of security just by doing that. And so I think with a lot of these cases, it just comes down to, if you have strong data security, like at its core, then it makes it a lot harder to do these things. There is still definitely a lot of things that are specific to machine learning kind of an adversarial AI attacks, but a lot of it can be mitigated with just good security, just generally.
One more point I haven't talked about yet with this type of attack is to augment the system with like proper registration for residents in that example that I was giving. So I come from a data engineering background, so if the data is already there, it would be great to just use it when we're putting especially ML application, ML stuff, or especially Gen AI applications in production. So if you can have a system where you're getting the residents to actually register and you're checking against that, that'll pretty much fix that problem. But It's kind of more of a reactive measure, and it doesn't protect the system from further attacks. You might have to have different databases for so many different cases, but I guess overall, just thinking about the system overall and trying to approach with security by design, as you're saying, rather than trying to fix things as they come up. To that end, here are some key takeaways that we've seen today and in work that we've undertaken for other clients. You can pick up and run with these pretty much immediately. The additional work is mostly not that much more than traditional SecOps. And the main points here are that you need to make sure that you're employing adversarial thinking throughout your development lifecycle, from ideation all the way through to deployment operations. Start thinking adversarial as soon as you've got your use case. And the bonus and the mindset of doing this, it becomes easier to reuse this framework going forward. Understand that adversarial AI practices can be extension of traditional security measures, as we've said, and that these go hand in hand. Working in tandem with your security team will give you a broader organization, the tools that you need to manage expectations with the wider business and empower others to understand the risks in the space. So security teams are your BFFs here. They'll always appreciate that you're thinking about security from the get-go, and they'll be able to provide you with valuable guidance, especially within the context of your own organization or problem. And finally, understand that adversarial thinking extends beyond just simply bad actors and attack services, as we've seen in the second example of poisoning, where there's not directly an attack, but it's still kind of just a vulnerability to keep in mind. Doing this will prevent surprising downstream effects. You can never go wrong with having better data governance or understanding your interactions between your use system better. As a bonus, we've put together a simple checklist of things that you can do day to understand the vulnerability of your applications. The first point here is understand that what you're trying to build and its vulnerabilities. So test your model against a variety of inputs, including malicious or manipulated attacks, and Sam will talk a bit about this later on. Understand your approach and application as a whole, your user personas and potential vulnerabilities for attacks, and place emphasis on logging inputs to help you kind of with continuous assurance and improvement journey. And build with security in mind from the start. So as we touched on a few times, from the very start of the development lifecycle, like plan as if you're going to go into production with it. Make sure you understand your data, your feature, the biases, and make sure you consider the model and system robustness from the get-go. Other one is identify risky patterns while in operation, have a plan for this. So I think, a few people mentioned this, we've seen this a few times, like try and monitor for any repeated or suspicious behavior. And the kind of approach for that, there's so many different approaches, but it's good to at least keep in mind that that's probably something that's going to come up and have an approach for it. Ensure that you bring your business along with you and help them understand why the work is important. We've touched on this in a few of the considerations, but most of the time, the business knows the customers, the users, and the processes, as well as the data, a lot better than us. So they're very, very valuable to have input from. Overall, it's important to understand that these style of attacks don't exist in isolation, and that sophisticated attackers can combine these types of attacks, as you can kind of see in the Oracle example. But don't forget that by locking down one of these types of attacks, you've secured your system against a much larger set of possible sophisticated attacks. And coming back to look at adversarial AI and LLMs in general, we've looked at a few applications and their vulnerabilities. Two of these were Gen AI related. One of them was just more traditional machine learning method. And we're here to talk about adversarial AI and LLMs. So let's take a step back and look at their vulnerabilities more generally. So this is a slightly overwhelming diagram from OWASP, which is also a great resource. I totally recommend you check out. They've got I think this is part of their report on the top 10 vulnerabilities for LLMs. You can see that there's a lot of ways that Gen AI applications can be vulnerable in different parts of the application. The different different attacks can be made at different points. So what we've looked at today are only the ones that are circled here, but you can see that there are many other areas that your application could potentially be exposed. But don't be alarmed. We've tried to look at a few of the areas to improve on, and Sam will talk a bit more generally about how to harden your application.
Beautiful. Thanks, Elaine.
Yeah.
So just in closing for us before we go to questions, we wanted to specifically talk about some LLM-specific considerations, just because I think, this is like obviously machine learning is, in its heyday at the moment, but large language models in particular are, we're seeing a huge surge in use in production, and I think without necessarily the appropriate considerations to adversarial attacks. From a large language model perspective, these map kind of very similarly to the checklist that Elaine was talking about earlier. But key things to think about is just like, where's the data coming from? Can it be accessed? What's the infrastructure look like? Again, to your point, if we can, attack the infrastructure itself, can we then attack the model through that? Robustness is massive for large language models because, they can just kind of go on a tangent and do their own thing. And, one of the first things that we always do with our large language model projects is just ask the same question 10 times and see if we get the same answer, or at least something similar, because it's okay if you get a little, if you're asking an FAQ question and it just gives you a slightly different style of answer and, but the content is the same, that's okay. That's the personal nature of using a large language model. But if it's giving you a different answer each time, or even if it's giving you a different answer 2 of the 10 times, that's not great. And that's something that you want to look at. Same thing around hallucinations. When we're doing tests on large language models, are the ones that our clients have built that we're then, kind of interrogating in more of a red teaming approach, or large language model applications that we're doing ourselves. Hallucinations are a big part of that. And, obviously there's ways you can kind of try and prevent that, using the RAG approach or something like that. But, it's something that you want to focus on and see, is this model going to be giving you factually correct answers? Harmful content, very similar story. Can users interact with your model in a way that would be harmful to the brand, would be harmful to the application? What happens? Does the LLM create harmful content? Can you get it to create harmful content? And Elaine touched on the kind of fairness, bias. I know, Jordan, you did the same, is that thinking about machine learning generally, you should be thinking about it from a responsible and ethical lens. When you're building models, when you're putting models in production, that should be the first thing you think about, even above adversarial attacks. You should be thinking about, is this model going to discriminate on a group of people? Because that's, going to be it's just way more problems than it's worth. It's not something that you want to be doing. And it can be, inadvertent. You can use a training set that is just biased towards a group of people, train a model, the model performs perfectly on the data set, but obviously isn't going to work well when you put it out into the real world. And large language models are no different. You want to make sure that if you've got something that, the parking fine example, is a good one. If you've got a model that you can interact with, that you're providing circumstances and, part of those circumstances you include, things like gender or race or, religion or other, other kind of demographic based data points, is it giving you the same answer? Because, for something like a parking fine, that should have no correlation. So that's something to think about, that, we want to make sure that you are getting a standard answer for questions, irrespective of what you were putting in there. Obviously, exceptions would be there if you're looking at things like insurance premiums, for example. Obviously, they'll discriminate on age. They always do. That's just the statistics. So things like that, very important to think about. And same thing with internal prompts. We saw that with the Bing chat. We've seen that, there's a myriad of examples where people have been able to prompt inject large language models and just get them to say the prompt. It's quite hard to stop. So that's something that, you do have to actually put quite a bit of work in behind the scenes to keep the large language model on track. But again, that's something to think about, how easy is it for users to break large language models? And that's something that, we've done a lot of work with some of the big financial institutions across ANZ and even, with engagements there, you get, some really cool applications that you then go and, try and test for some of this stuff. And it just, just breaks straight away just because no one's thought about it. No one's thought about the brand risk. I had an interesting one where they had an excellent architecture. It was working perfectly. And they dealt with all of the harmful content and they dealt with all of the stereotypes, discrimination stuff. but they hadn't thought about like the potential brand risk of having the model like respond in like gangster rap, which it was very easily able to do if you just asked it to respond to your query in gangster rap. And that's probably not a good look, you know, coming from one of the largest financial institutions in Australia. So again, these are just the, like, there's things that are going to be different for different clients, for different customers, depending on the, you know, the severity of these things going wrong. But that brings us to the end. I know that was a lot of content in the hour or so we've been speaking. So hopefully you took some things away. Happy to take questions now. Also, Elaine and I will be around afterwards, so happy to talk individually too.
All right, so let's give that more time.
Thank you. Yeah, I'll give you, got to get you a little lapel one.
Yep. Yeah, thanks. A lot of information. I have got two questions. One around the Mantel framework. Do you know any tools or that you can use, like for a model like ML or LLM, and give it the Mantel framework for ML and LLM, and do a benchmark of how secure your model is?
Yeah, from the large language model side, there are a couple of architectures. I'd need to actually, like, I don't know the name off the top of my head, but I know that there's a couple of open source projects that essentially try and package up that, like, considerations for large language models into an open source package that you can run against your large language model. From all accounts, a couple of our colleagues are using it for engagements. It works quite well. The only challenge is that because you need to download like packages as part of it from the various different, like if you want to do harmful content testing, you have to get like a package for that. It can be a bit funky if you're trying to test it on like a client site. But for like your own, like if you've got full development access control and full like, you know, like environment control, then yes, yeah, these things do exist. So yeah.
Yeah, the second question is actually Sam related to the OWASP. OWASP has vulnerable like applications when it comes to API or web app. And is it the same? Like, do they have any vulnerable like ML and LLM models also?
Yeah, that's where the diagram was from. And I think even in that paper where they list the top 10, it says it shares a lot of commonalities with their other publications, because a lot of it is just security fundamentals.
Yeah. I saw on the slide it was Gen AI. Is it the
they have a Gen AI specific one, which is where that one was from.
Yeah. All right. Thank you. That was.
Thanks for the presentation. I have a very specific question about LLM. So for RAG-based AI chatbot, what's the best practice to stop it from hallucination? Do you only, like, currently what we are doing is we just set a lot of restrictions on the prompt. Apart from the like prompt setting, is there any other ways?
My colleague actually did a specific talk on this, so I might try and see if there's a recording of that to be able to send to you, because there's a lot of considerations depending on how you set it up.
Thank you.
Thank you.
If I may, I suggest you Google RAG triad. RAG triad, yeah. It's sort of like 3 things you need to pin down to start dealing with hallucinations, and there's frameworks around it. So that could yield you some results.
Good talk, Elaine and Samuel. One thing, I'm not sure if this has been covered, but one thing I'm like interested in general is how would you approach, like, because like looking at the security considerations page, like how do you approach gauging like statistically how often certain prompts are answered correctly?
So in terms of like when the large language model is in production, like how do you kind of monitor that it's doing what it should be doing?
Yeah,
I guess. Yeah, I think like that's, you know, kind of part of just, I guess, a solid like MLOps foundation. And to be honest, we don't really see a big difference in the large language models that we do in like just general traditional machine learning problems. What we would recommend is that the first thing would be, have a process to have a ground truth, have like a golden data set where you've got essentially input output pairs for that large language model, where you have a set input and you have, as much as possible with an LLM, you have an expected output, or at least a rough idea of what the output should be. And with one of the clients I'm working on at the moment, we've got a set of about 100 questions that span, kind of levels of complexity from single words all the way through to like very complex paragraph questions. And when we're testing new large language models, or we're testing updates to those large language models, we use that gold standard. So we know, say for example, that Claude 3 Haiku, for example, performs excellently on the test set. We know that it works, it gives exact answers, run it this month, works this month, run it next month, assume it still works, we're happy days. If we're then monitoring that in production, we can then test that in say 4 months time. And if they've made a major change and, suddenly the whole model breaks to our system, we would then see that in the test set not giving us the answers. And what that does is it also doubles up as a way of testing new large language models as well, because we have a standard set of things that we're expecting and what answers we're expecting. So with that client, we're also testing out some GPT models, and we're also testing out some Gemini models, and it allows us to quite easily say, this is like for like, because we're able to test Gemini Flash and we're getting exactly the same or within margin results. I think the only difference I'd say for large language models compared to traditional ML is that traditional ML, you have a fixed output. If you're doing prediction or classification or something, like it's easier to say, if you say this word, that is sentiment positive, or that is, like problematic language or whatever. Whereas with a large language model, obviously the output could vary. So one thing that one of my colleagues is doing at the moment, which is working quite well, again, potentially compounding error with model on model, but is taking the output and running it through another large language model. It says large language models all the way down. This case, a much beefier, I don't think it's Opus, maybe Sonnet, 3.5 Sonnet or something, and is basically saying, here's the expected answer, here's the answer, are these similar? And we're seeing pretty good results off that. When you run that through a number of times, it says, this is fundamentally the same answer, or no, this answer is very different, and we can use that as a bit of an early warning sign. That's not as perfect as being able to still look at it, human to human, but it's not a bad way to do it at scale.
Hey, thanks for your presentation. With large language models, are you seeing in your client base generally that your clients are overly cautious or not cautious enough? Overly cautious in the sense that many companies I'm seeing were like, ooh, too many risks, let's just forget about ban large language models entirely, not look at them at all, or not cautious enough and implement something and exposing themselves to giant risk.
I think it depends on who you're talking to in the business. I think the cyber team of most businesses are pretty concerned. I think the IT security teams are pretty concerned. I think the business generally are pretty laissez-faire. This is, because I think the way machine learning, large language models are kind of that water cooler moment for machine learning where, yes, there's some amazing, there've been some amazing innovations in machine learning over the last decade, from ImageNet through to BERT, through to, kind of transformers becoming mainstream, but they don't attract the attention of your just business worker, of your head of, a particular line of banking, or, head of insurance or claims processing or whatever. Whereas when GPT 3 came out, or GPT 3 came out, and it was accessible and you could just talk to it and it would just do things like create songs for you and create articles for you, which was previously like just a huge amount of work, and it would just be beyond the comprehension. Like you'd sit there and go, give me a song about a happy frog called Fred, and it would just give you this 4-minute song. Like that's insane. That's so cool. It doesn't matter if the song's not very good, but it's still cool. And so I think that what we've seen is then that's been the moment that has like hooked people, and it's almost like the marketing paradigm that we had like years ago with like the cloud providers, where they'd be saying like, oh, this thing does everything. Like IBM Watson was like, rife of that. It's like, this is a thing that's going to solve all your problems. And then you'd go and talk to the research team and they'd say, it's going to be very good at solving this one problem. And I think that's what's happened, is that you now see this like almost like nebulous concept of a large language model that can do everything. And so you've got the business of like, well, I used this to create a song, so surely I can use this to automate my entire claims process. And then it's like, what do we need to do to get it to automate the claims process? So I think that we're seeing a lot of bullishness in the market from the business side specifically. And I think that even on the IT side, we're seeing almost an inevitability where like, even if you're staunchly like against machine learning, you're using, Office 365, or you're using Google Apps, or you're using, Zoom, or, maybe Skype, do people use that? I don't know. And so you're naturally dealing with machine learning, whether you're internally doing it or not. And so I think that like most large organizations have to deal with the fact that large language models are being used, whether it's through, their application, or whether it's through something like Copilot or, Confluence or, Canva, or something like that, where it's now in the hands and it's now, you can't put it back in the box. So I think that, I think we're going to see more and more cases come out. I do think we'll probably see a reversion to boring use cases, if that makes sense. Like I think for anyone who's been around machine learning for a long time, like things like document automation is like, it's just a perennial use case. Like I've done document automation probably 5 different ways. I think I spoke about it in 2017 when I was here last. Completely different way of doing it till we do it now, but it's always there because it's always a problem. Whereas like the really, all the people that are like, oh, we use large language models to, do blockbuster movies and to, like release the latest hit song and all the possible edge cases, I think those will probably they'll still be, dealt with in research and stuff, but I think that those will not necessarily get the uptick in like a business setting. I think it's just going to be your stock standard information retrieval, content generation, document automation, stuff like that is gets widespread adoption.
Thanks.
We have antivirus for attacks one way. How about a form of antivirus for attacks and LLMs?
Yeah, that is definitely in the works. I know like Google are pushing a number of products around like specifically like financial crime and specifically using machine learning on large swathes of data that they have access to try and identify malicious actors using products, using services, things like that. One of the traditional ways when you are trying to validate outputs of a large language model is to have a second large language model that sits as almost a checker behind it, and that one is hidden. The only way that can be interacted with is by the first model, and that's like, it's not entirely, I think, like it's not entirely that data prep stage, but it does act as a barrier in a similar way where it would be like, here's the question, here's the answer the large language model is given. It would then just shoot it off to the checker to say, hey, here's the answer and here was the question that was asked. Does this line up? That will deal with some examples. Things like data manipulation stuff, that's where you need to look at like, stuff that Elaine talked about, like watermarks and similar kind of, imprints digitally on documents, on images, etc., to kind of keep a chain of integrity. But yeah, it'd be on the data integrity at the front or like better model validation at the back.
So one was the RAG protection stuff and like checking relevance of the answers to the questions and stuff. So there's this company called TruEra. They've actually just been acquired by Snowflake. And they have generalized models for checking a few things that's happening in your RAG pipeline. So if you don't have the time or the resources to have like a big data set of model answers, what they can do is look at any answer and they can check it for relevance to your question, relevance to the data you've retrieved through RAG, and they can also look at the how well supported the answer is by the data that was retrieved by RAG. And they can do all of that with models which are generalized models to check basically any output from your RAG system to do that. So that's TruEra going into Snowflake. One was the antivirus for LLMs. So there is one or two organizations who basically have libraries of attacks that work really well against LLMs. There's a whole bunch of like formally classed attacks now for ways people can get your prompt or ways people can get your LLM to do stuff which is dodgy. And they also have like regular expressions and all kinds of stuff to detect them. So this is something which is starting to be libraryified. So it's worth having a look for that kind of stuff. It can act like a bit of an antivirus between the user's prompt and your model. Someone was also asking, how do you sort of stop people from asking a question that gets an inappropriate answer from the thing, like, and leaking the prompt or getting it to maybe retrieve data you don't want it to retrieve or something like that. I've worked on maybe like 5 or 6 RAG solutions now, depending how you count it. And this is something I've tackled. I don't know if it's like a 100% solvable problem, but there's some things you could do which I found to be really powerful. One is, which Sam actually alluded to, which is that model handoff. So what that looks like is you take the user's question, but the first LLM that it hits, the first prompt that you would use would be a very simple one that doesn't reveal much about how your question answering system works. It would just be basically, does this look like a question about agriculture, for example? If yes, like basically ask it to do a structured response, like one field would be yes or no, if it looks like a question about agriculture. And if it does, then the next field would be like reword the question about, like, give me a question about agriculture based on like, rewording this question. So the only thing you'd then hand on to your real model that does the RAG would be that field, which is like the reworded question about agriculture, and it hugely reduces the chance that they can do a 2-step attack to attack the second model, especially when you're giving structured output that can only be a question about agriculture. And the other one is to take the final answer that comes back that you intend to give it to the user. Before you give it to the user, you would give it to another model. All this is adding cost, of course, so it's about like, how much risk or mitigation do you want to do? How much do you care if your prompt gets exposed? How much sensitive data there is? But if you take that final answer and you give it to another prompt which simply says, take this content and reword an answer about agriculture from this, and like you might say like give the summary of the answer in this field, and give the extra agricultural detail in this field, and then you'd only return what those fields contain. You wouldn't contain the raw answer that came from so it's kind of like potentially 3 stages of LLMs, and if you do that, it's becomes exponentially more difficult to get to your really important prompts or to get any kind of nonsense response from it. Right, well, hey, thanks so much for a fantastic talk. I love all the resources you put up there. I think you could basically go and base a career on the stuff that you just shared in that talk. And thank you to Mantel Group for sponsoring, and thanks to AUT for the fantastic venue and for the catering.